Well, onward we go. Adding and subtracting radical expressions. Some people call these ninth grade problems because they're radicals. Oh, sorry. Anyway, adding and subtracting radical expressions. This works much like much of what you have learned in algebra so far. For example, if you're adding together variables, they have to be the same variable and they have to have the same power. X plus 2x equals 3x. If it were x plus 2y, there's nothing that you could do and it would still be x plus 2y. When we got to exponents, x squared plus x squared, you have two of these objects and they both have the same power, same basis, 2x squared. However, we could not do x squared plus x to the third. Even though the bases are the same, the powers are not. So that just remains x squared plus x to the third. So the concept behind what we're about to do, we've already learned. We have to have things that are alike before we can add or subtract them. Here's an example, and this isn't on your worksheet, but it's much like your worksheet. So we have 3 square roots of 7, that's how you would say it, plus 2 square roots of 28. Well, let's see, we have a radical to the second power, a radical to the second power. So the powers are the same. But we look in here, the 7 is called a radicand. Anything underneath the radical is a radicand. This radicand is not the same as that radicand. But I have it written down, so it must be somehow that we can do this. And in fact, we can. Now the number of 7 is a prime number. The only way that you can get it is 7 times 1. So there's nothing that we can do with this 7. But it's kind of a clue to us of what we need to do here in this one. In this radical, 28 is actually 4 times 7. 7 is prime, 4 is not. That comes from 2 times 2. So this equation turns out to be 3 square roots of 7 plus 2 times the square root of 2 times 2 times 7. Now, as you get comfortable enough with this process, you won't have to write it out this way. If you know that, hey, I've got a pair of 2's, I just bring them out as a single 2, then you can skip this step. If you're not understanding and you really have to work at each exercise, then please write it out this way on every exercise. Here we go to the next step. Any simplifying that we can do. We still have 3 square roots of 7 plus. Now here's a pair of 2's. That's going to come out as the single 2 and get multiplied to this one. So 2 times 2. The first 2 was already on the outside. The second 2 came from the pair of 2's on the inside of the radical. And that's where it came from. And the only thing that's left on the inside is 7. Now it's beginning to take shape. Now I have a radical to the power of 2 with a radicand of 7. And over here, a radical with the power of 2 with a radicand of 7. So as soon as we get through simplifying this term, then we can go ahead and do the addition. So 3 square roots of 7 plus 2 times 2 is 4. 4 square roots of 7. Same radicand, same power. 3 plus 4 is 7 square roots of 7. Okay. Like adding and subtracting fractions, when you're adding and subtracting fractions, the denominator stays the same. It doesn't change. When you're adding and subtracting with exponents, the powers stay the same. They don't change. So when you're adding and subtracting radicals, the radical and the radicand do not change when you finally get to add them together. It's still square root 7. You had 3 of them here. You had 4 of them here. So altogether you have 7 square roots of 7. Well, let's look at something a little bit more involved. How about this? Square root, square root, square root. 18, 12, 27. This is going to require a little work, especially if you're not very familiar or as familiar as you need to be with your multiplication charts. This might take quite some work, but you can do it. All right, I'm going to start right here. I know that 18 is 3 times 6. And 6 is 2 times 3. Now I have all prime factors for the number 18. 12 is 3 times 4. And 4 is 2 times 2. Prime, prime, prime. 27. 3 times 9. 3 is prime, and 9 is 3 times 3, prime and prime. Okay, so 3 square roots of 3 times 3 times 2. 3, 3, and 2. I wrote the pair right next to each other. Plus 3 square roots of 2 times 2 times 3. Plus 2 times the square root of 3 times 3 times 3. Now look at what we have. I know your inclination might be, hey, this is going to end up being square root 3. Well, some of them will be, some of them won't be. Let's go ahead and finish the process of simplifying, and then it will be clear what we can add together and what we can't. Right. Here we have a pair of 3's. So I'm going to bring that out as a single 3, and it gets multiplied to this one. So 3 times 3 is 9, and I'm left with square root 2. Plus, now here's the pair on this one, pair of 2's. So a single 2 comes out and gets multiplied to this 3. 2 times 3 is 6, and what I have left on the inside of the radical is just a 3. Here we have another pair of 3's. So a single 3 gets brought out and multiplied to this 2. 3 times 2 is 6. And what's left on the inside is a single 3. Now, to finish this up, these two can be combined. This one cannot. It's square root 2. Can't add it to square root 3. So it will come down into the final answer. 9 square roots of 2, then plus, because everything's being added, everything is positive in this one. I have 6 square roots of 3 being added to 6 more square roots of 3. That's 12 square roots of 3. That's the entire answer. No more simplifying. Nothing more can be done to this one. All right, give it a try. You can do it. Subtraction, Subtraction works the same way. If I had 9 square roots of 2 minus 5 square roots of 7 plus 2 square roots of 7, it's still only these two that can be combined. This would be in the answer, so 9 square roots of 2. This is a separate example, by the way. Has nothing to do with that. Negative 5 plus 2 is negative 3 square roots of 7. And that would be the answer. Give it a shot. You can look these up in the book, adding and subtracting radicals. Watch this video a couple of times if you need to. There is something that can be done on every one of these exercises. Give it your best shot. Thanks. Bye.